Have you ever looked up at the night sky and wondered why stars seem to flicker and dance? They sparkle with a life of their own, while other bright objects, like planets, shine with a steady, unwavering light. It's a sight we've all seen. You're outside on a clear night, far from the city lights, and the sky is a black canvas dusted with diamonds. You spot a particularly bright star, and it seems to pulse, changing in brightness and even shifting in color ever so slightly. Then you notice another bright object nearby. It might be Jupiter or Venus, but it's different. It's calm, solid, and still. This creates a simple question. If they are all just distant lights in space, why does one twinkle and the other not? The secret isn't found millions of light years away inside the star itself. In fact, stars are not actually twinkling at all. They are giant balls of gas burning with an incredibly constant and steady light, much like our own sun. The real reason for the twinkle is much closer to home. The magic show is happening right here, in the air above your head. The hidden culprit is Earth's atmosphere. That invisible blanket of air that lets us breathe is also what makes the stars dance. Think of the atmosphere as a deep, turbulent ocean of air that we live at the bottom of. It might seem perfectly clear and still to us, but it's constantly in motion. The air is made of countless tiny pockets and swirling currents, some warmer and some cooler, just like water in a river. These pockets of air have different temperatures and therefore different densities. This is the key to the entire mystery. To understand what happens next, we need to talk about how light travels. Light travels in a perfectly straight line through the vacuum of space. For millions of years, a star's light does just that. But in the last tiny fraction of a second of its journey, it hits our atmosphere. And that's when everything changes. When light passes from one medium to another, like from space into our air, it bends. This effect is called refraction. You've seen refraction before. Think of a straw in a glass of water. It looks bent or broken right at the water's surface. The light from the straw is bending as it moves from the water into the air before reaching your eyes. The same exact thing happens to starlight. As it enters our atmosphere, it starts to bend. But our atmosphere isn't one single, uniform layer. It's those thousands of churning pockets of warm and cool air. So the starlight doesn't just bend once. It bends again and again and again, in random directions as it passes through each pocket. Imagine trying to look at a coin at the bottom of a swimming pool while someone is splashing around. The image of the coin would wiggle and warp. The star's light is on a similar bumpy ride. Our turbulent atmosphere constantly jiggles the ray of light. By the time that single beam of starlight reaches your eye, its path has been bent so many times that it appears to be coming from a slightly different position each millisecond. This rapid shifting of the light's path makes the star seem to dance around in the sky. Sometimes the light is bent directly toward you, making the star look brighter. A moment later, it's bent slightly away from you, making it look dimmer. This constant, rapid change in brightness and position is what our brains perceive as twinkling, a phenomenon scientists call atmospheric scintillation. This brings us back to our second question. If the atmosphere does this to starlight, why doesn't it do the same thing to planets? The answer has to do with distance and apparent size. Stars are incredibly far away from us. Even the closest ones are so distant that, to our eyes, they are effectively a single tiny point of light in the sky. Because all the light comes from one single point, our atmosphere can easily bend and distort that entire point source. Planets, however, are much, much closer to us within our own solar system. While they might look like points of light, through a telescope you can see they are actually small circular disks. So we aren't seeing one point of light from a planet. We are seeing thousands of points of light from its visible surface. Each of these individual points of light is being refracted and bent by the atmosphere, just like the starlight. But the effect is averaged out. While one beam of light from the top of the planet is being bent down, a beam from the bottom might be bent up. These tiny distortions cancel each other out, and the overall image of the planet's disk remains stable and steady in our eyes. So the twinkling of a star isn't a property of the star itself. It's a story about the light's epic journey to reach you. It's an illusion created by the final, chaotic moments of that journey, as the light navigates the churning ocean of air that protects our planet. This is why astronauts in space see no twinkling at all. Above the atmosphere, the stars are just sharp, steady, unwavering points of light. The twinkle is a uniquely Earth-based phenomenon. It is a visual signature of our own living, breathing atmosphere. It shows us that the air above us, which seems so empty and clear, is actually a dynamic and complex place. The next time you look up and see a star shimmering in the dark, you'll know what you're really seeing. You're not just looking at a distant sun, you are witnessing a beautiful interaction between the cosmos and our own world. That little sparkle is a reminder that you are looking at the universe through the wonderful, wobbly lens of planet Earth.